Hey guys, it's finally clear. It's been at least 3 weeks, and so let's get to it. We have Venus right there beside that light. The moon is just right there, that light in the tree there. Jupiter's really high up over there. And Saturn, I am not sure. Oh, there it is. Saturn's over there. Still about over there. Okay. It's a bit windy though today. Right now, it says it's -1 Celsius, but it feels like minus 12. Or sorry, it feels like -11 Celsius, which is about 12 Fahrenheit. The wind is about 51 kilometers an hour. Now, the good thing is I got the fence and I have the building, so it's blocking most of it. But there is some wind. If I was out in the field somewhere, this probably, as you could probably see, I don't know, by that tree, would probably not work, or that tree. I think it would be too windy. But here I'm mainly protected, probably 80%. But anyway, let's see if it works out. Hopefully the wind doesn't screw me over, but we're gonna try the Takahashi Sky90, which is an f5.5. Against the, I know this is a doublet with a fluorite lens. This is a doublet achromat. This is a 102 f5. They're kind of very similar. They're short tubes, 90 millimeter f5.5, 102 f5. So I want to see if there's going to be humongous color difference, that type of thing. And let's just see what happens, Yes, I know sometimes a couple people might say, how can you compare a doublet ED to a just achromat? But this is what I like to do, to see, is the color blur kind of similar for each telescope in its size class, or is it a dramatically better? I have also heard in the forums, not just once or twice, a few times, where people have said, why can't they make a short tube refractor? So I guess like an 80 millimeter f5, or like that one, a 102 f5 or a 120 f5 with an ED lens. And some people just don't understand. It's just not about correcting for the color aberration. The steep curve of it is going to make the image quality much, much harder to produce, and most people aren't going to like it. But anyway, so let's try it out. What's the difference? A short tube ED, so this is one, against a short tube acro. And is installing a 1 ED lens gonna make a drastic improvement? So this is what this video about. So I know one or two still might say, well, you still can't compare, an ED against an acro, but it is what it is. I'm gonna do it, and that's it. So let's get to it. They only been cooling down for about maybe 20 minutes, but maybe by the time I get set, put the eyepieces in, maybe it'll be about 30 minutes, which hopefully is okay-ish, okay? But because it hasn't been clear in a long time, I haven't been able to refinish this test, so let's get to it. Okay, so the good news is, because the focal length on these two are very close, they're only 50 millimeter focal length, we could use the same eyepiece, and it's practically only gonna get 1 or 2 power difference. So we're gonna do that, so that will be a little bit better. So as you guys can see, this telescope doesn't have a motor drive, and I'm hoping it's gonna be fine. I don't have the big EQ6 because these guys are really small and not that heavy, so I'm hoping again that's going to be okay. I'm gonna be moving the scope over here, so that way I can face you guys and it'll be easier to talk to. So right now I got an 18 millimeter super wide because they're really low power. I don't need to put something too low. Okay, at low power, or lowish power, on the Takahashi, looks good. The phase is a little hard to see. Let's try this guy. Oh, that's actually surprising. It's actually white. There's no chromatic aberration in this one. Okay, so let's put it at focus. Let's see what we get. Oh, okay, yeah. You could definitely tell the purple around it easily. I mean, which is to be expected, I guess, on this guy. Okay, let's bump up the power. Let's see what happens when we put a 4.7 Meade ultra-wide Japan, the 4000. So I consider this to be a good eyepiece. Okay, out of focus at a 4.7. I'll figure out the power after. It still seems white color to me. Let's see what we have. What happens here? Okay, out of focus. Yeah, you still get that color fringing on this one. And on focus, okay, lots of color. Yellow, purplish. Let me go back on this one. No, it's like a half of Venus. It's much more clear on this one. Hands down, this one is the winner. Now let's go to something, let's go to Saturn. It's still pretty decent in the sky. Actually, it looks like it's probably about 20 degrees now from Venus. No question. It's a huge difference in chromatic aberration and contrast on Venus, at least. Let's go, okay, on Saturn, on an 18 millimeter super wide. Okay, put it in the center. But you could see the ring. Okay, it's really petite. You can also see chromatic aberration on this one, or it looks more like yellow. So let's see what we get in the Takahashi. Yeah, it is small. You can also see the ring. There's a few stars around there. Has more of a whitish glow. Okay, let's go back up to the 4.7 Meade ultra wide and see what we get here. I don't know how high of power I can go because, as I said, a little bit windy today. Let me put it in the center of the field of view. I mean, tell you the truth, it's not. I'm looking, there's a couple stars now at the edge, and you know, they say if it's miscollimated, they shouldn't be pinpoint. However, the stars to me seem to be, and this is at a high power eyepiece or mid-high, a 4.7, don't look too blurred or miscollimated to me. I'm gonna move it towards the center and see if it sharpens. Okay, it's okay, nothing great, but let's try this one and see, is it worse than this one, or it looks actually very similar. You know what, guys, I have a feeling maybe the collimation on this one is a bit off because it's not coming into tack like sharp. It's okay, I would say, but not great, I would say. Let me move it towards the edge. Again, the sweet spot on this focus is very small. The image seems to be, I thought it would have been better. Tell you the truth, on Saturn, I thought it would have been better. So I have a feeling now. On the Venus, it looked, the chromatic aberration, it definitely was better on the Takahashi, but the sharpness is actually kind of lagging a little bit. So, yeah, okay, so I'm going to conclude this one is miscollimated, and I think I might know how to do it, but the problem is then on Saturn, they seem to be about equal. I would expect this one to be sharper, but it's not. So maybe that's the end of today's session until I collimate it or try to align it. Then we try this test again and see if it sharpens up more. Then I'll know it worked. So right now, we took a look at Venus. Now we took a look at Saturn. So next video, maybe once I align it, we take a look at Jupiter, maybe even Mars, I'm not sure. So anyway, let's end the video right there because I want to see if it is miscollimated. Will it get sharper if I try to collimate it or not? Because I don't think I'm getting the best views out of this one. Saturn should be much better. Even though it's a short tube, it's a fluorite, I would think, let me give it one more opportunity. Yeah, I mean, it's okay. Now, okay, I want to see if I can fix it, and then we'll continue this test. Okay, guys, we'll be back, part 2. Okay guys, I think I have it at least 8.5 to 9 out of 10. Much better than before. That other video a few weeks ago that I tested on it, I barely saw the stripes. It was very kind of mushy, but I seen it, but wasn't as good. So this one, and I didn't even blow up the power. Now remember that one, I was using also a 2x Barlow. But okay, that's actually good. So I think, there you go, collimation done. Is it 100%? No, but it's very good. Somebody could probably do it a little bit better than me if they have the time. And just keep going back and forth. It's hot under here, even though it's cold. Yeah, that's better. Okay, let me see if I can continue this. I've ever done a refractor alignment, and it has to be on the Takahashi, which is very expensive. So I think I did a good job on it. And let's see now. Maybe what I'll do is, I'm gonna take this off. I don't normally do it this way. Put this down here, and I don't even have the shield on it either. I don't normally take the scope off, put the other scope, because, you know, I like them side by side, but because of what happened here, let's give it a try. Okay, so I can tell the image is good, and the banding on this one is like a little bit sharper. So I have a feeling now that one is probably at about an 8.5 out of 10. Not perfect, but good. But the color chromatic aberration on this one is a lot. So that one needs a little bit more collimation. But I think once that guy is fully collimated, it's, as far as chromatic aberration, it's not a little difference, it's a humongous difference. Some new people, okay, will probably say, oh, besides the color being a little off, like there's a green tint, purple tint, you know, you can see the moon's fairly nice, you can see the banding, it probably would be okay with it until you go something more expensive. So this conclusion, that is way better. I don't see any color like aberration on that one. So I think that probably compares to about an f10 telescope, at least, if not even maybe a f12. Oh, I just cracked, it's so cold, I just cracked the slow motion control plastic rubber part. Maybe that's a sign, you know what I mean? To get out, go inside. For this video, on the next video, let's compare it to a 90mm, which is the same size as that one, f10, and let's see if that color aberration is the same, less, or a lot more. And we'll go from there. Joe Jaguar, like, comment, and subscribe. If you know anybody getting into the hobby or on the forums, please share my channel and link. It is cold today. Why not you? Why not me?